We're going to go ahead and jump into some arc length examples that are algebra intensive. We want to find the arc length of 6xy equals x to the fourth plus 3 from x equals 1 to x equals 2. So here, we are not given y explicitly solved for x, but we can easily do that by dividing by 6x. So we're going to go ahead and start out by saying y is equal to x to the fourth plus 3 over 6x. And our interval is from x values 1 to 2. So now we're going to move on to finding the derivative of this function before we set up our arc length formula. So I'm going to go ahead and split this up before taking the derivative so I don't have to use the quotient rule. So if I split this up, this is equivalent to 1/6 x cubed plus 1/2 x to the negative 1. And so my derivative, y prime, can now be found using the power rule. So I'm going to have 3 over 6, which is 1/2 x squared, and then minus 1/2 x to the negative 2. Let's go ahead and set up our arc length integral. We're going to have the integral from x equals 1 to x equals 2 of the square root of 1 plus my derivative function squared. I'm going to write my derivative as x squared over 2 minus 1 over 2x squared, quantity squared, dx. All right, so now what I have to do inside here is distribute everything out and then combine like terms. So again, going to be pretty algebra intensive. Here we go. We have the integral from 1 to 2 of the square root of 1 plus, we have x squared over 2 minus 1 over 2x squared times another copy of x squared over 2 minus 1 over 2x squared dx. And now we're going to go ahead and distribute things out here. So I'm going to have 1 plus, if I multiply x squared over 2 times x squared over 2, that's x to the fourth over 4. And then if I multiply outer here, so I'm looking at x squared over 2 times negative 1 over 2x squared, the x squared over x squared is going to cancel. So I'm just going to have minus 1 over 2 times 2, or minus 1 over 4. And then inner is going to give me the same thing when I multiply these two pieces here. And I could see that x squared over x squared canceling out and just leaving me with negative 1 over 4. So another negative 1/4. And then finally, multiplying the last terms, I'm going to have plus 1 over 4x to the fourth dx. And in this next step, we're going to combine our constants. So 1 minus 1/4 minus 1/4 is going to give us a half. So I'm going to have the integral from 1 to 2 of the square root of, I'm going to choose to put x to the fourth over 4 first, 1/2 next, and then 1 over 4x to the fourth last. And the reason for that is because what we have going on here underneath this radical is this is going to factor to a perfect square. And so if we recall from previous math classes, when we have a squared plus 2ab plus b squared, this factors to the quantity a plus b squared. And it'd be great to have a perfect square under here so that the square root and the square cancel and we can move on with our integration. And so this part under here turns out is of this form. So let's go ahead and verify to ourselves that that is the case, because it might not be super obvious with the way that it looks. So x to the fourth over 4 is x squared over 2 squared. And then I'm going to focus on the last term. That's 1 over 2x squared, quantity squared. So the question is the middle here 2ab? So this is a, x squared over 2. This is b, 1 over 2x squared. Is 1/2 2ab? Well, let's check. So plus 2a, x squared over 2, b, 1 over 2x squared. So we're checking, is this all multiplied together just 1/2? Yes, it is. So the x squareds are going to cancel, and then 2 over 2 is going to cancel. So I do just have 1/2 left, right? I do just have 1/2 left. So I'm actually just going to erase all that. And we have just 1/2. And so that was just a verification that this really is going to factor to a perfect square. All right, let's put our dx back here. So again, the whole idea is that now I have the integral from 1 to 2 of the quantity a plus b squared. So again, a is x squared over 2, and then b is 1 over 2x squared. Now, over the interval from 1 to 2, we can go ahead and cancel the square root and the squared. So we're integrating from 1 to 2. And I'm going to think about this as 1/2 x squared and then plus 1/2 x to the negative 2 dx. So I'm canceling these, but then I'm also rewriting these to get set up to integrate each one using the power rule for integrals. So now I'm going to take the antiderivative here. So we're going to have x cubed over 3. So that's going to give us 1/6 x cubed. And then here, if I add 1 to the exponent, I'm going to have x to the negative 1 over negative 1. So that's going to make this negative 1 over 2x to the negative 1, evaluated from 1 to 2. And let's go ahead and substitute in 2 into each x. So 2 cubed is 8. So I have 8/6 minus 1 over 4. Where's that coming from? If I plug 2 in here, since there's a negative exponent, it drops to the bottom. This is 1 over 2x, so 1 over 4. And then we're going to have minus, if I plug in 1 into each x now, I just have 1/6 minus 1/2. And I'm going to skip the arithmetic and say that the answer here is just 17 over 12. Now, I'm going to give us an alternative to the algebra that we did up here. It's still going to be algebra, but just a different set of steps, different way to get the same answer here. All right, I scrolled up to the part where I had the integral from 1 to 2 of the square root of x to the 4th over 4 plus 1/2 plus 1 over 4x squared dx. And that's when we took a moment to pause and say, well, this actually happens to factor to a perfect square trinomial. But what if you didn't recognize that? Well, here was an alternative set of algebraic steps we could have followed. So what we could do from here, so I'm going to go ahead and move on over to the right, is I could have found a common denominator across all three of these fractions here, and I could have brought them all together. So I'm going to have still a big square root symbol, and the common denominator is going to be 4x to the 4th. That's the least common denominator. So I'm going to have a big fraction here with 4x to the 4th on the bottom. And let's think about what's going to be on the top. So there's already a 4 on the bottom of this fraction, so I'm going to need an x to the 4th on the bottom and on the top, which makes the top an x to the 8th. So I'm going to have x to the 8. And then 1/2, okay, well, on the bottom, I have a 2. I want it to be a 4x to the 4th. So I'm going to have to multiply the top and bottom by 2x to the 4th to get the common denominator here. So the middle term is going to be plus 2x to the 4th. And then the last term just stays the same because it already has a denominator of 4x to the 4th. So I'm just going to have a plus 1 there. Okay, so now the numerator here is a trinomial. And it's a trinomial that we can factor. And so this might be a little more recognizable as something that we can factor. It's in quadratic form. So here's how it's going to factor. I have the integral from 1 to 2. And then I'm going to have x to the 4th plus 1 times x to the 4th plus 1 is how the numerator is going to factor. So if I distribute it back out, I get x to the 8th plus x to the 4th plus x to the 4th. That's 2x to the 4th plus 1. Well, that's a perfect square, right? X to the 4th plus 1 times itself. So I can think about this as x to the 4th plus 1 quantity squared. And the denominator, we can also rewrite as something squared. So this is 2x squared squared. And this is still underneath the square root. And so what we can do is, now that they're both written as a quantity squared underneath the square root, on the interval from 1 to 2, I can go ahead and cancel these out. So I have the integral from 1 to 2 of just x to the fourth plus 1 over 2x squared dx. And now I can split this up to integrate it. So I can integrate from 1 to 2, 1/2 x squared, and then plus 1 over 2x squared dx. So I'm doing this whole karate chop thing. So x to the fourth over 2x squared simplifies to 1 over 2x squared, and then 1 over 2x squared. And from here, that's basically, now we can kind of move on over this way. So we have 1/2 x squared. We can rewrite this as 1/2 x to the negative 2 and move on and get the same answer. So that was two different set of algebraic steps to get us to the same conclusion. Now let's find the arc length of y equals e to the x over 2 plus e to the negative x over 2 on the interval from 0 to 2. Let's start by taking the derivative. Here we have two terms being added together, so we could do each one separately, and each one is going to require a chain rule. So this is like e to the 1/2 x. So we're going to have y prime is equal to 1/2 e to the x over 2. And then here we have e to the negative 1/2 x. So the derivative of the inside is that negative 1/2, and then e to the negative x over 2. Now let's set up our integral. Our arc length is going to be the integral from 0 to 2. And then I'm going to have the square root of 1 plus my derivative squared. So I have 1/2 e to the x over 2 minus 1/2 e to the negative x over 2 squared dx. Just like the previous example, I'm going to have to multiply this out. So this is going to be, like 1/2 e to the x over 2 minus 1/2 e to the negative x over 2 times 1/2 e to the x over 2 minus 1/2 e to the negative x over 2. So I'm going to have to distribute all of that out. So I'm just kind of writing it underneath this time. And so now I'm going to have the integral from 0 to 2, the square root of 1 plus, so if I multiply 1/2 e to the x over 2 times 1/2 e to the x over 2, I'm going to get 1/4 e to the x. Where's that x coming from? So when you multiply two things with the same base, we add their exponents. So x over 2 plus x over 2 is just 1x. Then what we're going to do is we're going to multiply outer and inner, right? So we're going to multiply the outer terms together, and those happen to be the same as the inner terms, right? So we have 1/2 and negative 1/2, that's a negative 1/4. And then let's focus on e to the x over 2 times e to the negative x over 2. I'm going to write those next to each other for a second and then talk about what happens. So if I multiply these, they have the same base, so we add their exponents. Well, these are opposites. So if I add those, I'm going to get 0. And e to the 0 is 1. So I just have this minus 1/4. This isn't really there, which is nice. And then inner, those are the exact same thing. So I'm going to get another minus 1/4. And then finally, we're going to multiply the last two terms together. And that's going to give me negative 1/2 times negative 1/2 is positive 1/4. And then we're going to have e to the negative x over 2, e to the negative x over 2. What happens when I add those together? Negative x over 2 plus negative x over 2, that's negative x. So we're going to have e to the negative x. And then just our dx. Okay, so now I'm going to rewrite this as the integral from 0 to 2, big square root. Let's see what happens. So I have 1 minus 1/4 minus 1/4. So that's 1/2. And I'm going to go ahead and put that 1/2 in the middle. And then I have 1/4 e to the x. Okay, so I want to remember how that perfect square worked out last time. I wanted something quantity squared. So if I want to rewrite 1/4 e to the x as something quantity squared, we know 1/4 is going to have to be 1/2, but e to the x is going to have to be back to e to the x over 2 over 2. So let's just convince ourselves, right? If we multiply x over 2 times 2, that gives us an x, and then 1/2 squared is 1/4. So that's this term here. 1 minus a fourth is 1/2. And then, okay, let's talk about what's going on over here. So I have 1/4 e to the negative x. So I can rewrite that as plus e to the negative x over 2 quantity squared dx. And it does turn out that this middle part, 1/2, is 2ab. So if I multiply e to the x over 2 and e to the negative x over 2 times 2, I'm going to get 1/2. So this is going to factor to that a plus b squared. So we have the integral from 0 to 2, the square root of a plus b e to the x over 2 plus e to the negative x over 2 squared dx. So this right here is of the form a squared plus 2ab plus b squared, and that's why we know it factors to quantity a plus b squared. All right, so now on the interval from 0 to 2, we can go ahead and cancel the square root and the squared and be left with 1/2 e to the x over 2 plus 1/2 e to the negative x over 2 dx. And we can go ahead and integrate each term here. So we're going to get, let's see, this 1/2 x up here, we're going to multiply by the reciprocal, which is a 2, and that'll cancel with the 1/2 in the front. So this is actually just e to the x over 2, right? I mean, think about it. If you take the derivative, you get this. So that works out. And then here, negative 2 is going to pop to the front, multiply by that 1/2. So negative e to the negative x over 2. And this is evaluated from 0 to 2. Let's plug in 2. E to the 2 over 2 is e to the 1 minus e to the negative 1. And then minus e to the 0 minus e to the 0. Okay, well, that's the same thing, so that's gone. So my answer is just e minus e to the negative 1, or 1 over e. E minus 1 over e. So again here, what's going to happen often, but not always in these problems, especially when they come from like a textbook, is that the part underneath the radical is often going to factor to a perfect square trinomial. And just to be clear, there's also from algebra, if I have a squared minus 2ab plus b squared, this factors to the quantity a minus b squared. So things like this are worth recognizing and remembering.